We're going to go over dispatchers today, gameplay message systems versus interfaces, where you might want to use one versus the other. So the standard Unreal dispatcher, which I think a lot of you have experience with, you have a dispatcher, this may be an actor, and it sends messages out to anything that's subscribed to it. Kind of looks like this. You can make these in C++, you can make them in the blueprint code. And then when an actor, like a new actor or a new object, we'll call this receiver, when it wants to respond to some event and it doesn't want to have to constantly pull this object, the dispatcher, for information, it can subscribe to one of these events. So it goes to the dispatcher and then it says, hey, when you are dispatching some information right here, make sure add me to the list. I like to listen to that. Right? So what the dispatcher in this case, it doesn't need to know about the receiver, but the receiver does have to know about the dispatcher so it can sign up to subscribe to this event. And what that does is the dispatcher then has a list of all these receivers, and when they subscribe, and then it goes through and it goes, oh, I want to dispatch the event. Okay, I'm going to let these people know, and it sends messages to all of them, letting them know, hey, I'm doing this event. Right? So what's nice about this is very direct. You, as the receiver, know specifically that this actor here is doing something, and I'm going to respond specifically to that. Great example of this is spawning a UI element and then interacting with it. Right? So if we go to our, I'm just going to search GA drop element art. Okay, so we have a pod drop item. So this is a gameplay ability that a player can spawn, and when it spawns this ability on start, what it's going to do is it's going to, if it's local, it's going to spawn this widget on the layer of the modal. With that, it's then going to bind to the event craft confirmation and bind to the event widget deactivation, right? And so if we go back to our system here, the gameplay ability is subscribing to the UI element with a dispatcher, and then the UI element, all it needs to do is it needs to we'll put in craft, and we see we have this little craft select, and it has its own internal logic where after it's done this event, it's getting the stack, it's getting information about the character, and then it's going to event handle this confirm action, and then it's going to call this delegate, right, which anything subscribed to it is now going to receive that message. And then when it deactivates the window, we've also subscribed to the deactivating. It's a little very straightforward system where we have a object and we have a receiver. And in this case, I'm not really worried about another object, say the grass or something else, wanting to know specifically about this widget. But you could see in that situation it might be difficult because this object, the receiver in this case, it went ahead and it created the dispatcher, and then the dispatcher being created, this object here doesn't really know where the dispatcher is, right? Does it subscribe to every single object ever made and say, hey, do you have this event? I mean, this is sometimes done in the real engine. For instance, with player spawn points, every single actor that spawned in the game, it goes, hey, are you a player spawn point? If so, add it to the list of player spawn points that the player can go from. And that works for level streaming in and out. Maybe not the best way to do it, but it is how the engine currently goes about handling player start points. So that's fine, but in a case where like this may want to be communicating to a lot of different things, we have what's called a gameplay message system. So a gameplay message system is the idea of, as the dispatcher, let me create a message to go out, and what I'm going to do is I'm going to give it a gameplay tag, and this is just going to go out into the wild, similar to before. Pew, pew, pew. And that's fine. Now, anything who wants to get information about this, they no longer have to, if I'm a receiver here, I no longer have to go to this actor and say, hey, I like to subscribe to these messages you're sending out. Instead, all they do is they say, hey, if anyone uses something of tag, let's say we'll just go with 1. So if there's any message that comes on tag 1, I am interested in that, and I like to receive that message to me as the receiver if it's tag 1. And then on as well as that is you could add some information to this message, which is included in a struct. So that information comes to the tag 1. It goes, yep, I'm expecting information on this channel, and as such I know that this is going to be of struct, or whatever you've declared it to be, and then I get to read this information and respond to it. So let's see that in action. The biggest fault for something like the downside for something like this is this receiver actually doesn't know which actor this was. So if you can imagine in a similar situation where a bunch of different players are doing some action and they're sending off information like, hey, I just jumped, and I just jumped, and you were sending that information out that all these players have just jumped in the air, then if you're receiving that jump information, then you might not know if this is the actor that you care about, because maybe you want to make a particle system for when the actor jumps, and maybe you only want to do it for the first player, right? Or your player. And so what you have to do is you're going to have to send a little bit of extra data that allows this object to really know what's going on and how to interact with that object. So let's see that in practice. So we just saw a great version of subscribing to a broadcast system. I knew this object, I just created it, so I went ahead and I subscribed to the object I just created, right? I was able to cast to it, so I already knew everything about it. But what about a situation where you're sending a message? So a great example of that is gas. So if we look at the GA Penguin gas, in this situation, what we're going to do is we have this ship and movement component, right? And the ship movement component has a ability can boost. It has amount of gas now. And this in this situation is not, it's not a gameplay tag, it's not a variable. It's specifically stored on this GMC movement component. So what we can do is when we first start activating the gas, We can say, hey, do we have gas? If we do have gas, go ahead and set B wants to gas. It's going to accelerate. The replication of this is already handled on this component. And then we're going to activate this camera, and even if gas was set to true or false on the PC, doesn't really matter because it has its other way it's handling its replication. But we still want it visually to look good. But what happens if they run out of gas? The character hasn't released the input yet. Well, we want to know that we are no longer gassing. So one thing we could do is we have the ship movement component here. We could go ahead and subscribe to a delegate that it has saying, hey, I ran out of gas. And then if we subscribe to that and it activates, we can go ahead and end the ability. But maybe there's a lot of other stuff that would be curious if we ran out of gas. Maybe we have particle effects, maybe we have UI, maybe we have all sorts of things that could respond to that moment. Hey, we ran out of gas, right? So, and you could still do that in here. This could send off in this gameplay ability, you could send off another tag or a GCN, gameplay queue notify. But what we're doing in this case is we're going to listen for a gameplay message. Specifically, we're listening for the ability ship.gas. And it just so happens they use this payload, the Lyra ability montage failure, which it has some information about the actor, the controller, the avatar, and it gives a little montage to play if it failed. And so on receiving this message, we're going to go ahead and end this ability. And one of the issues was, what if another ship ran out of gas? It would send off this message. So what we're doing here is it's checking the avatar actor and it's saying, hey, is this avatar, is this pawn, the penguin, the same as my avatar actor? If so, hey, let's make sure to end the ability. So it's not if it's some other ship. Now, what does that mean? That means this is going to get called and it's going to go through this little execution slip every time there's a penguin that's nearby that runs out of gas and sends off this ability. So that's kind of the pros and the downsides for something like this. So maybe you'd be like, you know what? We have too many penguins that are flying around. We really don't want to be having all of them listen to this gameplay message. And clear the camera in the state. But in this situation, we have to have a lot of things that want to subscribe, and they might not all be able to find the current ship, but maybe they know about the controller or the person who sent it off, and they can respond now to it. So what this allows you to do now is, if we go into this, these gameplay messages can be sent in anywhere in C++ or C#. All you need is have the struct available. So if we go into the code here, we can look, and let's jump into not a plugin. We'll go into a vehicle. We have a vehicle movement component, and then I'm just gonna find tag. Oh, is this not pushed? Okay. Oh, that's just not the one. This will be ship movement component. Here it is. So you can notice here, if the current gas time drops below 0, that's fine. We're going to set the gas to 0, and then what we're going to do is we're going to create this gameplay tag, create this message, go ahead and assign this actor. And, we didn't assign other stuff here. There's no ability montage being played, but that's all stuff we could add into this message, or we could make a different message. And then we're going to go ahead and send this message out into the world saying, hey, go ahead and broadcast this message, and anyone listening to this tag, go ahead and respond. So, as such, anything that was listening to it now can act accordingly. This is great for a lot of different situations, and it's used pretty extensively in the Lyra project, especially for UI. So what you can kind of imagine where this has more of its pros and cons. This one's an iffy situation of which way should we go about it? Maybe we should create a gameplay queue on actor and just subscribe to a delegate specifically that's created when you can boost. Some great examples of where sending out messages is really valuable are for objects that are just created in the wild. So imagine we have a big old music manager, call it MM here, and the music manager wants to control all the little sound actors that are in the world, right? And in this case, whenever a sound actor is created, right, what it might have to do is it would have to go find this music manager, and it would have to say, hey, I've just been created. Go ahead and subscribe to my events, and let me subscribe to your events so that we can have some communication, right? It can send the beat back to this actor so that it can respond, and at the same time it can say I am a hi-hat, I want to play on the 16th notes, other information, right? They want to respond. In this case, they have to constantly find this actor in the world. Anything that wants to maybe respond to the fact that music was created now has to either subscribe to this music manager and get more information about it, and it needs to send all this information out. Versus, in this case, which would be really valuable, is this actor could just send out a gameplay message saying, hey, in this case, I was just created. I play on the 16th notes. I am a flute or lead vocal. Call this the lead vocal. And then this music manager, what it can do is it can just send out a message on the lead vocal track saying play, right? And it wants to play on the next, bar. So then when this is listening for gameplay music lead vocal, it can respond and it can make music. And in the same way, this actor can respond if it's a vocal and it can make music. And all of these can be interacting and working with each other without actually having to specifically go out and subscribe and interact in a more rigid one-to-one fashion. And also, other actors aren't worried about getting clogged up with message because unless it's important to them, the fact that a lead vocal is playing, or the fact that some instrument is playing, or that it needs to respond to a musical beat, then those messages are just specifically handled on the channels that are most appropriate to them. And this is really valuable for items that are created and then all of a sudden deleted and created and deleted, and they're just popping up all over the place. Now they can respond quickly and efficiently to each other. All of this is with the Lyra common system. So it's not specifically to Lyra, but Lyra has these plugins called Common Game, Common User, Common Loading Screen, and these add a lot of modular actions. So even it's not well used in all of Unreal, and there's not a lot of tutorials just because the gameplay message system uses gameplay tags, which again are part of the ability system that Unreal offers. But even if you were making a game and you didn't want to use the ability system, I would really recommend picking up these common actors, common users, where you can easily send messages and tags and make a UI that respond to them. It's a very valuable plugin extension that makes it's well used in Lyra, but it also makes any game really valuable. Any questions on the messaging system that's available on Lyra and that can be pulled into any project? You there?
Sorry, I was muted. No, I think it's good. Makes sense.
Cool. I'm just trying to remember where, in this case, if you want to send a message, right, because this is just listening to it, in Blueprint it's the same code, you will just get the message get gameplay message subsystem like this. You can just you can send a message, broadcast, that's it. Broadcast message using the messaging. And in that case, your channel again is just a tag, and then your message will be a struct, and it's up to the listening actor to properly say, hey, I know the struct you're making. And again, I usually like to make the structs in C++, just so that in the same method, if you find out like, hey, I need some actor to be able to send it out, it has access to the struct that is being made. Otherwise, you won't be able to have C++ message. Even if it uses a tag, it won't be able to use the struct that the ability system would be expecting to listen to. So that's just one thing I usually kind of go about, is making sure I create structs in C++ so that there's not a bigger refactor later if you find out, oh yeah, we need to send this off from somewhere in code. Cool. Huh? That's like, we didn't go over interfaces. Interfaces just allow you to message something without having to cast to an actor, and that's what we see here, right? We've created this actor and we've cast to it, so now we can bind to specific events or call us functions. With an interface, you can call directly, and we can do a video about that another time.